React is very famous among developers for creating their front ends. In this tutorial, we will see how we can create the Azure DevOps pipeline, which will help us to continue integrate and CD. Let's see this diagram. We have our code in Azure repository. You can have any VCS. Then whenever the developer do some modification, do some commits or raise pull request, then CI pipeline will trigger on, which is hosted on Azure pipeline. Then you can see that this pipeline have some tests. I have mentioned the test, but you can add the test as per your requirement and what the needs fulfill you. Then build step. Then once we have artifact, then we deploy that artifact to Azure Web App. Azure Web App is we are not going to talk much in very depth, but Azure Web App is a platform as a service from the Azure where you can host your workload application. It's for multiple language like Java, .NET, Next, React, and many more. Let's see how we can proceed. We have already some videos, like you can see, of building Java web app, Android CI/CD web app, Android CI/CD. After build, you can deploy the Google Play Store. If you want to see this tutorial, you can visit this playlist. I will share link in the demo in the description. Let's come back to the today video. I'm sharing this file with description also in my YouTube video. So let's start the pipeline. It's in a YAML format. Let's have some format like on how it will be get triggered. So first part is the trigger part. Whenever someone do commits raise PR on the UAT branch, it will be get trigger. But Azure pipeline.yaml is our DevOps file. I don't want to get triggered when DevOps is doing. Whenever the task is done by or changes are done by the, you can say, dev, then only it should trigger. Then we have variables in Azure DevOps. If I explain you what are the variables, they are the values which can be stored as in secrets, and we can fetch them securely from library, which in behind the scene is getting the secret from the key vault as per your configuration what you select. Like here we have described the Sonar crate group. Under the group we may have multiple variables or variables which are mentioned as secrets. Then we have some local variables, you can say, which I'm declaring here agent image and giving its value as Ubuntu latest. Then another local variables like project folder and giving here its value dot means current folder. Then secure file, I'm giving this secure file a name .env.uat. So as you see, one, I mentioned the group from where it's fetching from the library. So library can fetch it through the key vault. So let's move. We have uses the stages. Stages is a kind of way of writing the YAML and distributing in a better way. Like you can make the build as per the high level function, like build one is one function and second one is the state deploy one. So whatever you are selecting or going to choose, how much stages you are going to create depends upon what you are writing there. So in most of the CI/CD you have two major stages. One is the build and another one is the deploy. Let's start. Under the stages we have job, which is build job, Under that we are calling the pool. Here we are using the Azure hosted agent, which is providing us the Ubuntu latest OS environment to build the React app. Then start. Here is a little catch. When you deploy the React application, you require a .env file. That env file will be shared by the dev. It will consist of the backends and other things like backend API URLs and others. That's provided by the dev. You have to. What I am doing, I am downloading the secure file from the secure file, and the secure file is the option under the library where you can upload directly the confidential files. So I uploaded that file by a name of .env.uit, and I'm mentioning here to download that file. So when this file get downloaded, this will get downloaded under the temp directory. So if you look at the next step, what I'm saying here, go take the temp directory as source folder and look for the secure file. Then target folder is the project folder. You already seen that it's dot means the current folder where the pipeline is running. Then clean. After that, you have copied that, clean that folder. Why it's required? Because you can think that this is the secure file. You can't leave that as it is. You have to clean that. Then we have the .env or .env.uit file in the current folder. Now we have to rename that to .env. So this is the bash command I'm using to rename that file. Otherwise your project will fail when you build that. And now we have the .env file, which is our dependency. Now we can go for the other dependency, as it's a React, and React is the framework of Node.js. We require the node. We can do the installation tasks. We can use the installation tasks which we are mentioning. I'm installing 65x. At which language your dev has written the code, you have to use that node module. Then we can come here to SAST1. Dependency are done here. We have .env, we have node, then we have SonarQube. Under that SonarQube we have, if you remember, we have a variable group sonar cred. Under that we have a key which I am calling here digital API key, which this key is required to check to configure the SonarQube, as this SonarQube is the, you can say, I have created a link between the Azure as a service connection. This is my service connection where authentication of SonarQube is stored. But in SonarQube we have multiple projects, so to deal with the multiple project we require a key. That's key generated and saved in the library group. This is key required because we want that the data should go to the particular project, not to the wrong one. Now we are done with all the necessary steps before build. Now we will run this script. First is the npm install. It will install the dependency. It will create the node modules in your temporary this Microsoft hosted agent. Once this done, it will take some time depending upon how much the modules you have written. Then you will run that command npm run build. When you run that command, the build will happen. It will also take around 1 minute of time. Then you have the build folder, build or something folder there. We will talk about that. Then we are saying that they do this SonarQube execution. Here we are using the SonarQube tasks, so we don't have to mention that where you have to go for that. It automatically check the code and analyze it. Once it's done the analyze, it will also take around 30 seconds to 1 minute. Then you can publish the report. Then by using this key, it will authenticate with via this connection, then the report will be sent to the target project under that SonarQube. Now we will copy that build folder to the Artifactory staging folder. Then we are publishing that Artifactory staging folder under the artifact name drop. Under that location is the container. Till now here our build process is done. Let me just go through once again before going to deploy. First we have declared the trigger, how my pipeline should get triggered. Some necessary variables which are required as an, they can't be optional, they are required one that required to build the application. Then we are downloading the secure file which we require in the React is the .env file. Then other dependency, node itself, we are installing the node required version. Then we are preparing the SonarQube via giving it's a proper key of the project. Then we are installing the dependency, building the project, then doing the SonarQube analysis, publishing the report, and the build is generated by during that build process. We are copying that to Artifactory staging, then we are publishing it. That once it get published, it will reach here and it will check. This is the deploy stage. What it's doing, it will deploy your artifact to your web app. But before doing it to web app, it will check it. Like you can set multiple type of things here. Like you are saying that whenever build come from the UAT branch, then only this stage will trigger. Otherwise, should skip that trigger stage. Means the code present in your web app is equal to code present in UAT branch. Then we saying that to be UAT environment. Then we are defining some variable that artifact is on drop. Then web app on Windows. That's just for the reference purpose. Then we have web app name. This is my web app name on Azure. This is my resource group name. Then this is the default system directory. Then I am defining a target URL. This is not required for the deploy, but I will give you why I have used that. Then we are defining again the pool where this deploy stage will run. Once it start, there is the environment, and under that environment you can do multiple things. You can set up the settings, permissions, who should can approve this deploy stage. Like it's not like that we are applying the delivery model. So whenever the CI/CD pipeline trigger, it will also always require the permission from the desired groups, desired members. So they are mentioned in that environment. Then we can proceed further. First step, we are downloading the artifact. Second step, we are by using this talk Azure RM web app deployment, we are deploying the web artifact to the web app. Web app is on the Azure, and we are our application or pipeline is on the Azure DevOps. How we are authenticating from Azure DevOps to Azure by using this Azure subscription. It is the service principle we have used to create the connection between there, and in the Azure we have mentioned or created a service connection by the name of SP, which have the credits of that particular service connection. Then we have web app name, resource group name, package for Linux. Then deployment will happen. Till now your CI/CD pipeline is done. So first you have done the deploy, and now you have done the first you have done the build, then you have done this deploy. There is one bonus task for you if you reach till that time of video. I'm doing something here. I'm doing the Docker installation, Docker version installation. Then I'm running this Docker command. This is the JDA proxy latest image, and we are passing our target URL there and generating a report. So then after that report is got generated, I am just copying that, and after that we are publishing that report to container also. When I explaining you the diagram, I said the deploy. Once deploy done, there is one more step. Then that is once the deploy happen, it is the test, dynamic application security testing. On the test, I have made a detailed video on my YouTube channel. You can browse through that and can benefit it. So if I explain you little bit DAST here. DAST is the dynamic application security testing. As we are already doing this scenario testing, but some code level testing is done. But once the application actually get deployed, this test happen then. Means how your application react after it's get deployed and it's get live. Then this OSJAP is helpful in that, and we are using that OSJAP test free tool OSJAP, and via this Docker image. There are multiple tools available. Some of there are free like OSJAP, and some other commercials. Feel free to use any of that. They are very helpful in improving their cyber security. Java is very popular language among dev for creating backend applications, APIs. In this tutorial, we will see how we can create a Java CI/CD pipeline on Azure DevOps. So welcome to our channel Tech on Target. In there are major components involved are the Azure DevOps suite, in which we have Azure repository as in VCS, where our source code of Java is stored. Then we have Azure pipeline on which some tasks are run. Then our destination Azure Web. Let's see this component in detail. As you see, when you do software development, you require some kind of VCS like GitHub, Bitbucket is there. Same your repository work, you can raise PR, do commits, all the Git operations are supported here. So you will start with the Git Azure repository, you will commit here, or you will raise any pull request. Whenever the developer is raising this pull request or doing commit, then a trigger will occur, and this trigger will initialize this pipeline. And in this pipeline, there are multiple steps, like we can differentiate them into the some testing steps, like the code you have written, it is valid or not. Some kind of checks like SAST. SAST is for implementing SAST, we can use SonarQube. SCA, we can use the Trevi. These testing techniques like SAST, SCA, and DAST, I have explained in my other video, so I'm not going in detail in this video. I will share the links in the description for this kind of testing in your CI/CD pipeline. You can refer that video for more details. So for now, you can consider whenever the pipeline, it has some component like testing component before build, then your application is getting built. In today's video, we are talking about the Java. So Maven is the build tool we use for the Java. And then when our artifact is ready, in case of Java, it's a jar file that we can deploy. We use the deploy step that will deploy into your destination, and destination is our Azure Web App. How this whole structure will look like, we will see in pipeline wise. It is our pipeline which we have written for our Java application. First, we have this trigger stage, like whenever it will trigger, it will trigger only when branch code review has some commits over it, but the commits should, if commits involve of this file Azure pipeline.yaml file, like this commit has some changes in this file, that it will execute, because it is our DevOps file, not developer file. We have planned or created this pipeline for developer only. So whenever developer is pushing or committing, releasing PR, then only our pipeline should run. Then we are using some system variables to define the name of the custom build. Then next section after trigger is variables. We are defining a global variables which can be used in any stage or anywhere in the pipeline. Like agent, we are using the Ubuntu latest. Ubuntu latest currently is Ubuntu 24.04. This pipeline is running currently on my system, like my setup is Ubuntu 24.04. Then we have stages, as we are doing creating the multiple stages in this pipeline. Let's see first stage. First stage is the build stage. Then in that what the name, when the pipeline done, what name that look like, that is build stage. Then we are defining some variables which are part of this stages only. Means if there are multiple stages in this pipeline, those pipeline can't use this particular variables. So there are some variables. In Azure we have a library. Under that we store the credits. Here our you can see that group is here, and under that group you can see db credit group we are calling. In that variable groups we can have multiple variables like db host, db url or username, password, etc. Then some variables which are declaring in the pipeline itself, they are not sensitive as db credits are sensitive, so we are saving in the variables groups only. Then we are defining here the copy artifact, what artifact you have to copy. I'm saying it that in the target folder you have lookout, and under the target you will have the jar file. Sonar credits, some like here the credits are stored in this variable. Sonar credits are stored in different group. Then we have project name. Project name is going to be used for the what we can say particular Sonar cube only. Let's see these jobs. Then under this stage we have defined the job. This is our build job which will use this agent image. Under that we have first task, it's the git leaks. In the diagram which we have discussed, SAST we discussed, but cred scan step we have not discussed. So you can add cred scan here also. So it will comes here inside that something here. So leave it as it is. Okay. Then what it's doing, like it check for, you have mentioned some API key, SSH key, anything that you have mentioned, it will look out for it, and if it is there it will throw you the exception. Currently that's okay. Let's move to next. We have Sonar cube. Sonar cube in Azure pipeline, either it is Java or different language. First you configure the Azure pipeline, like pipeline for Sonar cube, like this task Sonar cube prepare. It displaying this by name of Sonar, configure Sonar cube. Inputs I am giving Sonar cube service connection via name of Sonar cube. You can make any name. What it consists of? It consists of your URL or IP of your Sonar cube, its username and token. Then mode, some properties are there. Properties means project key. If I go just above, Here you can see we have project name. That project name means this my repository is available, or its reports can be seen in the SonarQube via unique project name. That's project name we are referring here. Plus, with respect to that project name, we should define a key, and this is the key for that project. Like if this key is matched, then only reports can be pushed or published to SonarQube. So we can move to the next one. If we summarize till now what we have done, then we move to the next one. We have the Azure repository as a source code repository where developer is doing commit or raising pull request, and then whenever they are doing that, trigger is running, which is triggering the Azure pipeline. Azure pipeline have some steps, like when it will get trigger, on which branch of basis, and which path it should exclude. Then first test is happening, correct scan, then SAST, SCA. Here SCA is not involved, but SAST is there. SAST is the SonarQube. There are more tools which we can use for SAST, but SonarQube is mostly used. Then we have Maven step. What is Maven? In Maven step we are telling him, like we are giving the location of the POM file. JUnit test we are not doing. Code coverage tool options, we are using Jacoco for code coverage, publishing the code coverage. JDK version, on what Java version we have created this application, and on what Java version we should build this application is 17. Maven version option is default. Most of them it takes the latest one. Maven authentication is false, then effective POM is also false. SonarQube NSS is run true, means whenever you do the Maven build, SonarQube NSS will run. That's the Maven task for you. Then we have, after this got success, we have a report. That report will get published to the SonarQube via this step. Then we have copy artifact step. Like when it's getting built, we have build directory. From that build directory we are copying the artifact. You have already seen that it is look for the under target folder, look for the jar file, and that jar file it upload to the target folder. Then we have publish artifact in drop. It will create a folder via name of drop. Under that it will upload the jar file. Then we have the next stage. In the next stage we have via name of UAT, it should be deploy UAT. So it will display as a name of deploy in UAT. Then it will always depend upon the our stage. It will not run independently of that. If first stage is failed, it will never run. Then we have some condition over here. This is the condition. What this condition is saying, if the build is coming from the UAT branch, then only it should run. Otherwise this particular stage will be skipped. So only build will happen, deploy will not happen on any other branch. It will make the system consistent. Like you don't have to worry about that. Like your environment, it will ensuring that your UAT environment always have the source code from the UAT branch. It will never going to be taken the source from code from the feature or another branch. Then we have jobs, under that we declare the deployment. It's using the deployment to UAT environment, that just display name, some set of variables they have defined or they declared. Then we have pool. On the pool we are calling the global variables. Environment is UAT. Environment is very useful in the Azure DevOps. Like when the commit come from the UAT branch, this particular stage will or a particular stage will be run. But unless some provers which we define in that environment, they approved. This stage will not, this stage will be trigger but not run. Once the persons as per the policy you set up on the Azure DevOps, so that particular stage will be done only after the approval. Then first we have environment, then strategies. Under that we are downloading the artifact, then which we have generated in the previous stage. Then we have the Azure RM deployment, which is used to deploy on the Azure app. Collection type is Azure RM. Then we have app type, and Azure subscription. We mentioned in front of that we mentioned the service connection. I have made the service connection by a name of SP. Then it's taking the web app name. For to look out the web app, it's required the resource group name. As you know, if you're working on the Azure, everything is bound with the resource group. Each and every most of, I think 99% of the component are created after the creation of the resource group. They are associated with any of the resource group. Hi everyone, welcome you all in another video of Azure DevOps. In this video, we will see how we can create an CI/CD for Next application. We have already completed 3 videos with React, Java and Android CI/CD pipelines. You can go through this playlist to watch these videos. Plus, on our channel we have another videos of monitoring, logging, cloud, Kubernetes, etc. You can browse them. If you require any specific topic or want to ask something, you can do comment. Let's start with the today video. Here is our public project via name of Azure DevOps on our, and it is a public repository in which you will find this folder. Next, under that you will find this pipeline file, which is an YAML file. Under that we have defined the code for the Next application. Let's see how this pipeline will work. First is the trigger section. Whenever you are doing some commits or PR to the UAT branch, then this particular pipeline will run. Then your first part is this pipeline is the trigger. Second part is the variables. You are using some variables of Sonar. You are defining a group of Sonar under that, and then you are defining a local variables of agent image you want Ubuntu latest. Here groups are the library groups, and we have created this library groups on the Azure DevOps by name of SonarCred, from where we will fetch our keys related to project. Then project folder, you will see how we are utilizing this variables. Then secure file by name of .env. Then we first one is the trigger, then second configuration was the variable, third configuration is the stage. Then we are maintaining here the multiple stages. First stage is the build stage, and then second one is the deploy stage. First stage is the build. Under that we are building the application by using the latest image. Then first things, there are some prerequisites. It's required .env file before continue. Then you can see it's downloading that secure file, and when we download the secure file, go to the temp folder, and from this temp folder we are moving it to the project folder. That's why we use that variable, and it is the repository where is our code is present of Next application. Then we have that files. Then here we are using SEST, and SEST tool is SonarCube. What is SEST? SC. We have a video on that. You can browse on our channel via name of application COD testing. Here SonarCube, we are creating the SonarCube, and we have already defined a service connection via name of SonarCube in our Azure DevOps project. So whatever the if you want to use SonarQube here, you will change whatever the service connection name you have, then its key, project key, whatever the key you have stored in library group, that you can call here. That's the SonarQube configuration part. Then we have another dependency node we require. Here our application is the node application, which depends on the node 16. Then first application is the npm install hyphen legacy pt flags. Here we are this particular command is installing the dependency for our project. Then npm run build, it creating the artifact, building the app and creating the artifact which will be used to deploy it. Then whatever we have deployed, on that we will run our SonarQube execute analyze. Then whatever is analyzed, the report will be submitted to the SonarQube platform that can be seen on the SonarQube. And then we have copy file. When we build the here important thing is, when we are building the SonarQube doing the SonarQube analyze, when we are building the next application, it will create the out folder, and in the out folder we are copying everything to this artificial state directory, and that artificial state directory we are publishing to the drop container. So till now we have completed the one stage of build. If we quick recap, first we have defined the triggers, then some useful variables, then we are creating some prerequisites like files, initial configuring the SonarQube, installing the nodes tool, then building the application, and after building the application we are analyzing with SonarQube, publishing the reports on SonarQube, and the artifact in the out folder we are publishing it to the artifact location. So till now one stage is completed. Another stage is the your stage. This stage will only run when the commit or PR commit is raised on the what we can say on the UID branch, and PR is merged on the UID branch. It is not PR is raised, PR is merged. When PR is raised, code is there in the UID branch, then it will run. Now this page is running. We are using environment features available in the Azure DevOps. So what this feature say, we can use that feature. What this feature say, this feature says that you can add some reviewers or approvers, like this is your code, it is going to be on your product or any environment. Now you have the environment declared over here, and the mentioned approver on that environment. Whenever this step will get trigger when the commits on the UID branch, but it will only run when someone approve from the approvers in this environment. So there are some another again variable. We are defining the variables here as they don't have any significance in the global level. They are just specific to this particular what we can say deploy stage. Here we are using the web app and its resource group, and defining its package for Linux. Here one thing, where we are deploying, we are not deploying on the virtual machine. There is the application web app by name of web app in the Azure, which is you can say PaaS, platform as a service by Azure. So we are just pushing our code here, which we have generated as an artifact. So here we are downloading the artifact, and then we are deploying by using the service connection, which we have name of SP. Then it is the location where we will publish it, and connection type is Azure RM. So this is all. Till now we first build, then deploy the next application on the web app, and that's our complete CI/CD. Azure DevOps is very powerful tool for performing the CI/CD and automation tasks and we will perform our Android app CI/CD today. Hi, welcome to Tech on Target, and in today's video we will see what are the steps involved in creating the Android app CI/CD via Azure DevOps. Let's start. First, configuration of the pipeline is the trigger part. How the pipeline will get trigger? It will get trigger when someone will do action, commits PR to the test branch, and some path I haven't excluded, like some DevOps file which are not relevant to developer, like Azure pipeline.yaml I have excluded. So whenever some action is happening in the Azure pipeline.yaml file, no trigger will happen. So pipeline will not get trigger when you are making commit PR in the Azure pipeline.yaml file. So that's easy to define the trigger part. You can include much more thing, exclude much more thing as per your project requirement. Then the second configuration part is the agent OS and parameters. We are using the Mac OS agent for our this CI/CD. Then we have some parameters. Parameters are like we can accept the inputs from the user while running at runtime when you start running the pipeline. So there are two parameters: release name and release notes. In the release note, you can mention what you are going to perform or what you are going to, some kind of notes for your reference. Then 232 is the release name, and under that 10.6 is the release version for me. Here 232, if release name you have mentioned in the last web mobile app you have uploaded to the Google Play Store is 232, then you can't upload the same. You have to make it 233, different from the last one. Google Play Store will not allow you to make the same app upload with the same number. You can keep the version number same. That you have to mention in your Gradle file. We are pasting it from here to get this published with the app itself. So now we are using the build approach, stages approach, to differentiate between the task, like one kind of task in one stage and other kind of in other stage. So we have the total two stages. One is the build stage, another one is the deploy stage. In the first in the build stage, first task is the install dependency task. In Android project, we use React Native community CLI as it use multiple modules of the React Native through the node modules. When we execute this command, the multiple modules which are mentioned in the package.json file and in your configuration file of the Android project, they will all get downloaded and present in your local directory for the use of the next processes. So this is the kind of prerequisite process, some dependency you are installing before the actual build process. And some use yarn, some use other commands, whatever the commands you get from the developer and how it configure, it may vary, depends upon the project to project. So if we talk about the next step, our dependency is now ready. All the files and modules and configuration things are here. Now we can move to the next stage. Next step is the build. We will use the tool named Gradle here, and it has some parameters you have to pass. You have to give the wrapper files, which is a Gradle view file where it's present. You have to provide that path. For me, it is present on the Android folder, and working directory, everything that build process will happen is under the Android. Then JUnit we are not using here. Java version. There are some files of that application which depends upon Java. So Java you also require, it's on the Java version 17. Then Gradle options, you have to mention the resources, how much resources you require for that build process. We have mentioned 4096, like around 4 GB of RAM it will require. Sonar cube analysis we are not doing, so that's why I mentioned false. And sport bug analysis we also not performing. So once this step will happen, depends upon still again upon your configuration, it will generate a artifact, either a APK file or a bundle file for you. So that's depends upon the developer and what the configuration he map. Then according to that, in my project we are generating a APK file. So what I'm doing in this step, I'm mentioning that there is a APK file, you have to copy that file, and from that when you copy that file, you have to publish that artifact in the drop folder. While publishing, like as we are working in different stages, deploy is under the environment, so it may be the reason it run after 2 or 3 seconds, or you may want to see in the future. So after publishing, you can see the at any time of your artifact. Now our second step is build stage. Here we are putting a condition like it's first run after the build. Whenever the build stage run, then only it run. Then second condition is the branch, like whenever whenever this pipeline run on the main branch, then only this build stage will run, otherwise you skip that. Then we are having the environment here like Google Play internal, and then by using environment is the features of the Azure DevOps. It's not the environment of your infrastructure, like you have the I have make environment via Google Play internal, and I have added some persons as a prover to that, and like Mr. X, when Mr. X approve that deploy, then only deployment will happen to the particular stage, otherwise it will remain in pending permission state. So then we have the release task. Build is already done. We have the APK file with us. It is uploaded in the publish artifact folder, and it will download it from under the drop. This is the location where it is present under the drop Android app build outputs APK release. Then it's there. Under that we are having the two parameters which we have discussed in the very early of this video. Both parameters passed here, and when the person on the Google Play Store will see, it helps or easy to recognize or recognize the app, which app comes from where, and some information as we are passing that this is the build number. It have very easy to recognize that. So at this stage, our CI/CD pipeline is done. What we have done, what we have achieved till now: a developer push a commit, the pipeline run, then it done the build, create the build, publish it, then our deploy stage run. When someone is approved from the approver group, it publish the APK file to the Google Play Store. Now this was the part of the CI/CD. What you require here is the service connection. Service connection is the property of the Azure DevOps. It helps Azure DevOps to authenticate with the other platform like Google Play Store, iOS, SonarQube, and many more. uh, here are some steps. Like you have to make the authentication. You have to enable Google Play Android Developer API on the Google Google, it's Google Cloud. Yes, on Google Cloud. Then you have to create a service connection there, generate a key there. That key will generate against a ID. That ID and key you have to enter in the Azure DevOps. Then it will start authenticated. Plus that ID you have to add as an user in the Google Play, and you have to give that permission to manage the apps. So that's in that way your authentication and authorization will work, and your pipeline will get succeeded. So there are some links which are very helpful while you will create the pipeline, because no pipeline is perfect. You have some customization steps with respect to your settings, your configuration, your requirement of your project. So like Google Play extension is there. You have to download it in the Azure DevOps Developer Console. You can check for the app ID and other things you require. Azure official doc is very helpful in that. Then setting up a service connection and adding that in the Azure DevOps plus setting up in the Google Cloud is very crucial. This link which I mentioned there is very helpful in creating the service account in the Google Cloud. So what I'm expecting here, there are some steps. Google, you already have the project on the Google Cloud because you already have the Google app with you. What you need to do, that's project. It's creating the new project. If you want to create the new project, you can go through that. Then when you click on that link, it will bring on this link. Then from here you can enable that. From here you will click on the next. Then you will select the application data. Then next, you will create a service account. You will give some name, meaningful name to your service account, some description to your service account, which will helpful in the future to for someone else to know that this was created for the Google Play Store. Then you will create that. It will bring you to the credential sections. Finally, before credential section, you will have to give some permission to the this service account. Like you will give the admin permission, service account admin, and IAM is not required here. Just adding the role is enough, and then you will reach to the, after creating that, you will reach to credential section. And in the credential section, when you click on the create credential, you will see a ID. That's very important. You note down it. That's will be different for you, unique for you. And against that, you will generate that JSON key, download it. It will something look like that. And now you have to go to the Google Play Store, and here you will invite the new user, and under that new user you have to pass the email ID, and that email ID you will pass here. And then when you pass here, invite the user, then you can see permissions, like adding itself is not work. You have to give the permission so that it have the authorization to add the new version of applications here. Then this task is done. There's only one task is remaining. I will leave it upon you, that adding that key and adding that extension in the Azure DevOps. That's very straightforward. You just have to visit these links. I will add this link in the description of the video. That will help you to get up to there and complete your CI/CD pipeline. Then this is the sample CI/CD pipeline available in my public GitHub repo. I will add repo's link in the description also. This is the this pipeline step we have already discussed in the presentation. Each and everything is same. It is just in single file, easy to copy, easy to perform, and you can perform demo on you. I was looking to perform demo, but first we discuss this Docker file. You can perform Ubuntu. This is a like a bonus for bonus point of this video I'm sharing with you. Ubuntu, you can use the Ubuntu to create the Android app. I'm using the image of Ubuntu 22, then adding some dependency over here, then installing the node, which is requirement here. If you have seen that we have used the macOS agent, Android app can be created on the macOS plus on Ubuntu. It's not like the iOS app. iOS will only be created on the iOS only, and through that Docker image you can easily create the. Now you require the Android CMD tools. Through that tools you can download that. And total when you will visit might be after 2 months, 3 months, or I don't know when. The CMD tool lines updated one will have the different version, so match the links here and get the updated one. And node version you also change as per your project. Then it's ready, and you can use this can say this particular Docker file to build your Android project. And that's very helpful actually. When I was trying some troubleshooting things on my laptop, I installed the Docker, and then through this Docker file I created the image and started building the our APK file. Hello everyone, welcome you all in another video of Azure DevOps. We have already made multiple videos of different CI/CDs, different stack CI/CDs plus Azure DevOps branchings. In today's video, we will see how we can make a CI/CD pipeline for Angular stack. So let's start. So this is a sample YAML file which you can use in your project where you are building and deploying the Angular application. So let's start. First section is the trigger one. It will get trigger when someone will generate or push commit to the UAT branch or raise PR to the UAT branch. Then we have variables. Under that we are using some group, library group, and defining the agent image Ubuntu, and we are using the latest image. Then first stage is the build stage, where we are using that image pool, and in the Azure pipeline we have the tasks under that. So first task we are using the node tools, and under that we are telling it which node version I want. So you can use or choose that version according to your requirement. Okay, that is the install Node.js. Then second is the script we are using. You can use bash and other scripts. Then what it's doing, it's installing the Angular CLI of particular version. That's again depends on your project definitions. Then we are installing the npm, and we have given this step name of installed, and all these things are happening in the source directory where the checkout happen of that code. And under that checkout, after checking doing the checkout of the repo, we get inside that repo. Then we have the sonar cube. In this sonar cube we have a service connection by name of sonar cube, and in the library we have defined its project key via name of this project key. Script, like if you are using the env is equal to prod, then this is our build command running in this script, and whenever person you must send parameter while running the pipeline, ng build hyphen prod for your production, and ng build hyphen configuration is equal to staging for your stage, depending upon that. And ng build, because you have in my project I have default parameter is the UIT. So if I'm not defining the configuration, not passing the configuration, it will run in the UIT. And then we get our artifact. Then one artifact is generated, we can run this analyze. One analysis is done, we can publish the report. These are the built-in tasks which we can use. Now copy task, whatever we have built, it gets saved by name of your repo or your setting, whatever the app name you have given. Then under the dist, it is the app UI, and we are making it to save in the binary. Then under that binary we are making it a zip file. Once zip file is ready, we are publishing the artifact. Okay, that's done. After artifact is getting published, our build part is done. Then we have this CI/CD deploy part, and we have make a condition like whenever the build come from the UIT branch, then only it get proceed. Then we have a UIT RG resource group. Under that we have UIT 1 web app, and the artifact which we downloaded, we will just we can say upload or deploy to the Azure web app. Here you can see we have the particular pipeline. Sorry, we are just downloading the artifact, and then that downloading artifact we are sending it to the Azure web app. Here it's using some variable which we have defined here, and you need a service connection to the Azure cloud. We have defined it by using service principal. So that's all for the today video. Everyone, welcome you all in another video of Azure DevOps. In today video we will see how can we implement branching strategies in Azure repos. It is our existing Azure DevOps playlist in which we have defined different CI/CD pipelines for different stacks, and in today's video we will see how we can apply branching policies and why we should require it. So let's start. When you create the pipeline or repository, you require some branches to be protected, like someone should not do it by mistake, and some policies, review policies, and what should be the necessary criteria of adding the code with that particular branch. Like you might have some feature branch, but you have that one main branch which should have that particular properties and particular set of rules that we will see. So that's about the properties. We will see in detail what are these properties are, but first we see how we can implement that in Azure DevOps. When you go to your repo which you want to apply the branching policies, then select the branch by visiting here in the branch section. Then you will find the branch like name here Azure Pipelines, and like you can apply it to main or whatever you want to select. Okay, then here is the next page. In your branch you will have these three dots. When you click on the three dots, you get the options, and under that different options you have one option of branch policies. When you click on that, you will come to here, and next to settings you have policies. Then you will get this list of policies which is present for you. You can enable and here things to be noticed like branch policies. If any required policy is enabled, this branch cannot be deleted and changes must made via pull request. If any one of this feature you have enabled, then that branch become protected. For example, I'm at the branch of Azure pipeline. If I enable that, then this pipeline can't be deleted and any change should be raised by PR only. So let's see this check one by one. So first policy is require a minimum number of reviewer. Like you have some application running on your main from code from the main branch, and someone want to add some feature in that branch. It shouldn't be like that. It raise the PR and then close the PR. Someone should review that PR, and once it review, should approve that PR. And you can select upon the number of reviewers, how much reviewers are required, and when this reviewer are required. There are some parameters like allow requester to approve their own changes. Like if I am the approver and I also want to do some work and contribute, and I added a new feature, so I should also be able to approve my changes. Then you should click on that. Then there are some other difference. Then we have check for the link work items. Work items are part of the Azure board, and you want that whatever PR is raising, it should be documented in the Azure board. So you will have particular work item with respect to the work you are doing, and that you will attach. If someone is not attaching, the PR will not get closed. It will throw you the error. And sometimes you add the comments like you are using the tool like SonarQube, and once the particular run we can say SonarQube analysis is done, then it shares some report, and if it's saying that some quality errors failed, then it will fail the PR. Until you resolve the all, you will not able to close the PR. Then you also have the limit merge types. Here you can add the build policy. Under the build policy, when you click on the build validation is like that. It will not do the deployment part, it will do the validation part. Like you have the pipeline in which you are creating a Java artifact. So when you are creating Java artifact, what will happen? You will create a Java jar file, and what you want, you will select that particular pipeline here, and you will say whenever someone is adding the new things, like adding the PR from the feature 02 feature 01 branch, and feature 01 code should get executed via this build pipeline, and if it runs, then you can only can PR be merged. Here you can select the pipeline trigger. This automatic policy requirement is required, and you can make that to last it. You can enter more than 12 hours. Like after the 12 hours, it will get expire. Build will expire. You can increase the time here. Then we have the approvers, like who will approve. Here you can add the people, like you my name is Stack on Target, I will add my name here, or we have group of approvers for UAT. Then I will create first the group, and then I will select here. Then its type should be required, and then all approvers, if their changes are made by them, they have made the changes, they can approve their changes also. So that's all in the branching policies.